So a matrix is invertible if and only if its determinant is non-zero. Right? Okay. This means if we have a matrix whose determinant is zero, then it is not invertible. If we have a matrix whose determinant is not zero, then it is invertible. All right? You should keep this point in your mind. It is useful in many methods and other theorems. A matrix is invertible. This means there is a inverse for a matrix if and only if its determinant is non-zero. Right? You want to ask something? Okay. Okay, great. So let's see an example of computing determinant. This is our matrix. This is given to us, and we are asked to compute its determinant. So if you remember from previous session, one method, one algorithm to compute determinant was to try to convert our matrix into echelon form. Echelon form is the upper triangular matrix, and it is easy to compute its determinant. Determinant triangular matrix is obtained by multiplication of its main diagonal elements or entries, right? So we try to convert a matrix to its echelon form, whose determinant can be computed easily, and we keep track of each operation. We keep track of the effect of each operation on determinant. We know that row replacement doesn't change determinant. Row interchange multiply determinant by -1. And row scaling by R multiplies determinant by R. Okay, we know already these things. So this is the matrix which is given to us, and we are asked to compute its determinant. We replace the second row, we replace the third row, -6, 7, -7, 4, with the sum of third row and 2 times of first row. And this is the resulting matrix. And in this matrix, you see that you have row 2 and row 3 with the same entries. Row 2, the second row, is exactly the same as the third row. So what is the determinant of such a matrix? What is the determinant of a matrix which has exactly whose 2 rows are exactly the same? What is the determinant of a matrix
0.
whose 2 rows are exactly the same? It is always 0.
Yes.
Why the determinant of a matrix whose 2
Because-
rows are exactly the same is 0?
Because after we multiply and minus, it will be 0.
No?
Because the second and the third row, second matrix are equal.
So then why in such cases determinant is 0?
If we minus one from 1, it will be 0, sure.
If we
Doctor, if it's equal, the minus will be 0. The value of all columns by row.
so then
This will be 0 because it's equal.
yes, then
The rows
what
is-
will happen after that? What will happen?
it will be invertible.
Yes,
Oh,
yes, you are right. So,
because all variable equal 0.
so when a matrix has two rows with the same interest, like this matrix row 2 and row 3, you can replace the third row with the sum of third row and minus of second row. In this case, the third row will become 0, right? And then when you use cofactor expansion around the third row, since all entries are 0, the result will be 0, right? So
yes, doctor.
that's the reason why when a matrix has two rows with exactly the same entries, its determinant becomes 0. Similarly, when a matrix has two columns with exactly the same entries, its determinant will be 0. You can replace one column with the minus of another column. This operation also doesn't change determinant. And you will have a matrix with column whose entries are 0, right? And when you do cofactor expansion around that column, a column whose entries are 0, the determinant, the result will be 0, right? So in general, let me give a plus to Mr. Nuruddin Sopi, yes. In general,
Yes, doctor.
when you have a matrix which has at least two rows with the same interest, its determinant
Yes.
is 0. Or
No.
when you have a matrix which has two columns with exactly the same interest, its determinant will be 0, right? Okay.
Yes, doctor.
وشنو يا دكتور؟
So let's move to the next theorem. Next theorem says that determinant of a matrix A and its transpose, A transpose are the same. So a matrix A and A transpose have the same determinant. Determinant of A transpose equals determinant of A, right? This is also an important point. You should keep this in your mind. Please let me repeat this. A matrix A and its transpose, A transpose, have the same determinant, right? Okay. So please keep this in your mind. Determinant of A equals determinant of A transpose. Okay. A question. Okay, I will ask you, I will ask this question later. Let's move to the next theorem. We have two n times n matrices A and B. A is a square n by n matrix, B is a square n by n matrix. Determinant of AB equals determinant of A times determinant of B. So this theorem says if you have two matrices, it doesn't matter if you first multiply them and compute AB and take determinant from AB, or equivalently, you first take determinant of A and determinant of B, then multiply the determinants. In this slide, there is a mistake. The second A over here should be B. So determinant of AB equals determinant of A times determinant of B. So you can correct this mistake. Determinant of AB equals determinant of A times determinant of B. Right?
Right, Doctor.
Let's see an example of this theorem. A matrix like this, 6, 1, 3, 2. Here is a matrix like this, 4, 3, 1, 2. And what is AB? What is A times B? This is A times B, and you are very familiar with computing matrix multiplication, and this is A times B. Right? So then, what is the determinant of this resulting matrix? What is determinant of AB? You know, right? It can be computed easily. 25 times 13 minus 20 times 14, right? Something like that. For a 2 times 2 matrix, you know how to easily and quickly compute determinant, right? So determinant of this matrix is 25 times 13 minus 20 times 14, right? And it gives you this result, and in the end, 45. Determinant of AB equals 45, right?
Okay, Doctor.
Okay,
Correct.
so this is determinant of AB. Now, tell me what is determinant of A? This is A. What is determinant of A?
It's 8,
Nine.
Doctor. 9. 9.
Yes, it is 9.
8.
Yes.
It's 9. Correct.
And what is determinant of B?
It's 5.
5.
It's 5 because 4 times 2 minus 3 times 1 gives you 5. So you see determinant of A times determinant of B equals 45, and it is equal to determinant of AB, right? So you see an
Yes,
example
Doctor.
of this theorem. So it is very important to keep in your mind that determinant of A plus determinant of B is not equal to determinant of, determinant of A plus B. So let me write over here. Determinant of A plus B is not equal to determinant of A plus you should keep this in your mind, right? Then you have multiplication. Yes, determinant of AB equals determinant of A plus, times determinant of B. But when you have sum, determinant of A plus B is not equal to determinant of A plus determinant of B, right?
Right.
Okay, great.
Okay, Doctor.
Okay, let me ask you a question. What is the relationship between determinant of A and determinant of inverse of A? What is relationship between determinant of A and determinant of A minus 1?
قلنا عليها
It's equal 1.
What is equal 1?
معناتها
Uh,
كمل.
the terminal A
Yes?
multiply determinant a minus 1.
Yes, equals
Identity.
1. Yes. Yes.
Yes, it's identity.
Identity, doctor.
This
Maybe.
means this means uh, this means determinant of A. This means determinant of A is the inverse of determinant of A minus 1. The reason is that you have, let me do this. You have A times A minus 1 equals identity matrix. You can take determinant from both sides, determinant of A minus 1 equals determinant of I. This means determinant of A times determinant of A minus 1 equals 1, because determinant of identity matrix is 1. So you have this relation. Determinant of A times determinant of A minus 1 gives you 1. This means determinant of A minus 1 is the inverse of determinant of A. Right? So this is also an important point. Please keep this in your mind. Okay. Okay. Let's move to the next series of slides. If you don't have any question until now.
Thank you, doctor.
Okay. Okay, great.
Okay, doctor, we have a question about the final exam.
Yes, ask your question.
Do you have any important question about this final exam, I mean?
I gave you, we have some chapters, right? And from these chapters, we are teaching some sections. From each chapter, we are teaching some sections. For example, from chapter 2, we ignored LU decomposition, but we taught other other sections. So those sections that are taught in the class, it's better you go and solve some examples from them.
Yes, doctor.
What examples? Let me think. What examples? You have the textbook and you have the manual of textbook. If you can solve those examples in the textbook, you wouldn't have problems in the final exam. So it is not the case that I have a certain set of questions and choose some questions from them. Most of the questions will be the questions of your textbook or some other questions at that level, at the same level. So if that question in the exam is not exactly in the textbook, then it would be at the same level as questions and examples in the textbook. So I highly recommend you go through those examples and questions in the textbook and try to solve them. And you have manual. You can check the your answer with the manual, and also some of you can sit with together and try to solve with together. The thing is that now we are not, we don't have that much time. We are running a bit out of time. We have, apart from this week, we have 1 or 2 other weeks, and we have many materials that we should teach about exam, right? Some of you suggested to have 2 exams. Or it could be okay, but let me clarify this. If I take 2 exams, there will be no way that I ignore your score in one of those exams. So your score, your grades in both exams will be important. They will be equally important. So your final score will be the average of these 2 scores. So it is not like this that I take 2 exams and then give you this opportunity to, to ignore the score of first exam or second exam. No, we will, if we have more than 1 exam, the final score will be the average of your scores in all exams. So I don't know. If you really insist, we can take 2 exams. The thing is that first, we don't have that much material. Second, we are a bit running out of time. It would be generate some problems if we spend one of our classes for the exam.
Okay, can we have some help about presentation for every student?
You mean you give a presentation and then no? The thing is that first of all, the nature of this course is a bit different from giving a presentation. The best way to have help for you is that you acquire some classes in the class. So until now, let me 1, 2, 3, 4, 3, 7, 8, 9, 10, 11, 13, 15, 18. I have given 18 classes to different students. Some of you have obtained several classes, like 3 or 4 classes. So the best way to help you is first you attend classes, not online classes, but also in-person classes. It is very important. Second, you answer the questions that I ask you in the classes, or you can solve those assignments that I give to you in the classes. This is the best way that I can help you. When I give you some exercise that you solve at home, I can check it if you have solved it by yourself or not. But when I ask you questions in the class, I can check it. I can be very sure that you are answering this question or you are solving this question by yourself. So already quite some students have obtained classes from me. 18, I have given 18 classes to different students, and these classes are very important, right? So you can try to get classes in the remaining sessions. This is one way that can help you. The other thing is that I can take 2 exams, but your final grade will be the average of these 2 exams. It's up to you. If you agree, I can take 2 exams. So let me know who wants to have 2 exams. Please raise your hand if you want to have 2 exams.
Yes, doctor, we want to have 2 exams.
So all of you, please
Doctor,
raise your hand.
I mean, this the second exam. It's all of student.
Yes.
Some of student is is good for the first class, the first exam.
واللي يعيد
So
امتحانين خليهم
should we
فعيدة
have
يقولوا
another
فاديكم.
second exam?
No. Everyone should attend both exams.
اخوان
Second,
ضميت الامتحان ايش وقت راح يبدي هذا الثاني؟
all students should attend both exams, first exam and second exam, and your score, your final score, will be the average of these two exams.
اخوان قاعد
So
يقول
next
نمتحن الميد
next
والفاينل
week
والدرجه تكون معدل.
next week we can have exam if you like. Next week on Saturday or on let's say on
No, please, Victor, salam. Assalamu alaikum. Victor, next Saturday we have exam
امتحانين
in
نهائي
algorithm.
فمو مال الامتحانين النهائي.
Sorry,
محمد
who
بس دقيقة.
of you are talking together? I don't understand. Please speak one by one. Yes.
ما دا يقول
Yes,
امتحان
Victor.
باكر، ما دا يقول امتحان باكر.
Doctor, next
محمد
Saturday
بس
we have
لحظة.
decided to how we can. Doctor, please. You said that next Saturday that we decided how to we be the exam and the days.
لا اخوان، هو ما دا يقول امتحان السبت، دا يقول اللي يحب ياخذ امتحانين
Discuss it together, right? Okay, discuss it. And tomorrow, please let me know what is the result of your discussions. If you want to have two exams, it's okay. Next Sunday, that you will be here by person. We can have an exam. In the case you agree to have two exams, we can have it next Sunday and by person, right? When you are physically here in the place.
Please, Doctor.
And
Please, Doctor.
and your
Excuse me,
final
doctor.
score will be the average of both exams.
Excuse me, doctor.
Doctor, next
If you
Saturday,
have
next Saturday.
لحظة
next
حسين هسه
Saturday.
راح أقول لك. Excuse me, doctor, if you have a time, if we decided to have two exams, then the exam gonna be next Saturday. That's right.
Next Sunday.
Sunday.
The Sunday of
Other or okay, Sunday. Okay, the other students, some of students have algorithm mid-exam next week. So they find it very difficult to getting two exams in the same week.
So the thing is that we don't have other time because the week after the next week will be the last week, and after that you will have your final exam. So the thing is that I'm not sure that if we don't have exam next week, I'm not sure that we will have time for it in the week after next week.
Okay, doctor. الامتحان إذا حددتوه حيكون على الأسبوع اللي يجي، ولازم الأسبوع اللي يجي لأن ماكو وقت، لأن حيكون الأسبوع يجي هو تقريبا قبل آخر أسبوع للمحاضرات. فدا يقول في حالة إنه أنتوا قررتوا تسوون الامتحان يعني اثنيناتهم، فلازم الأسبوع اللي يجي على يوم الأحد. وقلت له إنه أكو طلاب حيكون عندهم امتحان، قال حتى إذا عندهم امتحان ماكو فرصة ثانية
الأحد ما
للامتحان.
نقدر الأحد
هو دا
ما
يقول
نقدر قولي له ما نقدر
لحظة.
لأن عندنا امتحان.
زين شنو
هو
المواضيع؟
مو
اذا فد موضوعين بسيطات يعني هذا بس حددي المواضيع.
اي اذا
هو
يا
مو
هواي ما
أنا
نقدر.
اللي أقرر، سواء كان بس لحظة يعني هيك سواء كان الامتحان الأسبوع الجاي، هو دا يقول ماكو يعني فرصة ثانية، سواء عندكم الجوريثم ما عندكم الجوريثم، هو لازم الأسبوع الجاي يصير الامتحان إذا قررتوا إنه نمتحن. تمام؟
يوم ستة
خلينا نشوف المادة.
ساتردي.
أسئلة عن المادة؟
اي
لا،
خلي
بنرجع
قليلين
المادة.
المادة يعني كلش قليلة يعني حتى الوقت
زين.
يفيدنا.
فقط الشابتر الاول اذا مصير زحمه، فقط الشابتر الاول.
ويوم
Okay.
ستة.
Then, doctor, the student just asked about the material that's gonna be accessed on across this exam. It's gonna be the first chapter or the first and second and the third.
So the first exam can be based on materials of first and second chapter, or maybe just first chapter. It's up to you.
If you don't mind, they just asking to have only the chapter 1.
Okay. Okay,
If we
it's fine. So
decide
we
to
can have
have the exam
one
next week.
chapter now. Yes,
اوكي
it's
اساتذه
fine.
يقول ماكو ثانك يو دكتور. يقول ماكو مشكله اذا تريدون الامتحان الاسبوع اللي يجي نخليه بس تشابتر 1.
تمام على بركة الله.
ويوم
هسه
سبت
شنو؟
يوم سبت
والخوارزميات واحنا
ما ادري هاي بعد انتم يمكم. هسه شنو اقول له انه راح
شباب هو
نتناقش
شابتر
وعلى
واحد
باكر
شباب
نعطيك
دكتور
القرار
هم
النهائي.
لحد
صوتي إذا خلي يكمل
يقول
الدرس
لي
مالته
لباكر، يقول لي
ونتناقش
لباكر.
عود ونطول خبر، بس خليه يكمل.
يعني
تمام
هسه
يعني
شنو؟
خلي المناقشه بعدين وخلي
خلي
باكر
المناقشة
لا،
بعدين،
باكر
خلي
نعطيك
الأستاذ خليه
الخبر.
يكمل وبعدين نكمل نسوي ميتنج نتناقش فيه. خلي يكمل
ان
الأستاذ
شاء الله.
ويوصل.
Okay, doctor. They said they're gonna discuss our opinion and give you the decision tomorrow. And they just ask you please continue your lesson and thank you very much.
Okay, good. Okay, so please
Yeah.
discuss among yourself, and then we can please let me know your opinion by tomorrow, and then we can make our decision tomorrow. So let's continue our discussion on the course. So
Okay. Doctor.
the next topic is Kramer rule. So what is Kramer rule?
grammar rule.
So let A be a invertible matrix. So we know that A is invertible. Invertible n by n matrix. And B is some arbitrary vector in Rn. So we already know that X equals B when A is invertible, has always a unique solution. We already had a theorem for this. When the coefficient matrix of system of linear equations A is invertible, then the system of linear equations has always a unique solution. Ax equals B has always a unique solution. What was that unique solution? Can someone remember?
It's have
Sorry
one
again, Doctor.
So
You can.
So we have this Ax equals B. This is a system of linear equations, right? Ax equals B. Right? This is system of linear equations. And A is invertible. When A is invertible, we already had a theorem that this system of linear equations for every B has always a unique solution. What is that solution for every B?
If Doctor is AX is not 0 and the B is not 0.
What is that
That
solution?
means it's not have three variable.
Just one solution.
So what is that one solution? What is so
That
what is
solution
the
that's
value
given,
for
Doctor,
X?
that's given by value of I.
FLB is
Value of
non-zero.
X3.
FLB is non-zero.
هذا اكو قطع الكهرباء
It means every variable
B is
have
not 0.
value.
وان شاء الله بس
What
يكون
is
رجع ان
that
شاء الله.
value of X? So we know Ax equals B. What is the value of X?
The value of 1, 2,
A minus 1B.
It's X. The value of X, A minus 1B.
Doctor, it's A minus 1, A inverse B.
Right.
It's
Yes.
X equals
And that's inverse of A.
So this is the solution. This is the value of X. Then we have Ax equals B and A is invertible. Then X equals A minus 1B, right? This is the solution. This is the value of X for this system of linear equations. We already knew this. We already had a theorem for this. Now, this theorem, theorem 7, says that this x also has this value. xi equals determinant of aib over determinant of a. What is xi? Xi is the entry I of x. Xi is entry I of x, right? And what is determinant of aib? What is aib? aib is a matrix in is the same as A, but in its column I, we have put vector B, right? We have replaced its column I by vector B. This is AIB. So let me write over here. This is A, and this is column I of A. This is column number I of A. So if we remove this column from A and put B here, the resulting matrix will be AIB. So actually, AIB is the same as A, but its column I is replaced by B. So this theorem, theorem 7, which is known as Cramer rule, says that xi, the entry I of x, equals determinant of A IB over determinant of A. Is it clear to you?
Doctor, that's mean A1B, A2B,
Yes,
A3B.
it means x1, for example, x1, which is the first entry of x, equals determinant of A 1B over determinant of A. So what is determinant of A1B? What is A1B? A1B is the same as A, but in its first column, we have put vector B. Its first column is replaced by vector B, right? This is A1B. A1B is A, but its first column is replaced by B. So this is x1. In a similar way, x2 equals determinant of A2P over determinant of A. What is A2B? A2B is the same as A, but its second column is replaced with B, and so on. xn equals determinant of A NB over determinant of A. And what is A NB? A NB is the same as A, but its
N
last
column.
column is replaced with B, right? So is this clear to you? Is theorem 6 clear to you?
Please, doctor, can you repeat that?
So let me to solve an example. Let me first try to showing this by an example, and then if it is not clear to you, we will get back to the theorem. So consider the system of linear equations, right? So what is matrix A for the system of linear equations?
3 minus 2, 6, minus 5, 4, 8.
Yes, exactly. It is 3 minus 2 in the first row and minus 5, 4 in the second row, right?
Right.
And what is vector B?
6, 8.
6 minus
6,
2, 8
8
and 4.
minus 2, 4.
6, 8 is B. 6, 8 is a vector and it is B. 6, 8. So,
Yes, doctor, it's 6 and 8.
so 3 minus 2 minus 5, 4 is
عليكم
8
السلام ورحمة الله.
and B is 6, 8. So, what is A1B?
استاذ نور الكهرباء فايتين
The matrix A replace the first column with the B. 6, 8.
Exactly. So, AB is something like this. This is B, and the first column is replaced by B. The second column is the same as the second column of A, right? Is it clear?
Yes, doctor.
Okay.
Yes, doctor.
So what is okay?
Okay,
Great.
okay.
Matrix A replace the second column with B.
Replace the second column with B.
Column 2 by P.
Exactly. So what is A2B? A2B is matrix A, but the second column is replaced by B. So this is the second column, and this is replaced by B. So you have 3 minus 5, the first column exactly the same as matrix A, and the second column is replaced by B. So in the second column of A to B, you have B, 6, 8, right?
Right, sir.
Okay, is it clear until now?
It's okay until now.
Okay, great.
So, doctor, how we can consider the unique solution here? How we can find A inverse B?
So let me continue. We will get to that point. So until now, is it clear to this example until now? Is it clear?
It's clear for now.
Okay, so we want to find the value of x1. This is system of linear equations. We want to find the value of x1 and the value of x2, right? Okay. Theorem 6, the Kramer rule, says x1 can be computed using this theorem. Determinant A1B over determinant A. So this is A1B. What is determinant of A1B?
24.
What is determinant of A1B?
62.
24.
26, doctor. لا 6 by 4, 24 minus 16.
24 plus 16.
It's 40.
40.
40.
So what is the result?
It's 40.
It will be 40, doctor.
Yes, 40. You are right. It is 40. So determinant of A, it is 40. And what is determinant of A? This is A.
It's 2.
It's
3 multiply 4 minus 10.
Yes, exactly.
It's 2, doctor.
So yes, x1 equals determinant of A1B over determinant of A. Determinant of A1B is 40 and determinant of A is 2. So x1 equals 40 over 2, which is 20. And similarly, x2 equals determinant of A to B, determinant of this matrix. What is determinant of this matrix?
It will be 54.
54.
54.
Yes,
54.
it is 54. And what is determinant of A?
It's 2.
So x2 equals determinant of A to B over determinant of A. It is 54 over 2, which is equal to
27.
27, right? 27, right? So you see, in this way, we can compute x1 and x2. In general, if we have n entries in vector x, We can compute x1, x2, x3 to xn, right? xi equals determinant of aib over determinant of a, right? Is it clear to you now? xi equals determinant of aib over determinant of a.
Doctor, this xi, what is represented?
So xi is the entry I in vector x. And what is vector x is our solution. Our solution for this system of linear equations. So ax equals b is a system of linear equations, right? It has a solution because a is invertible. So we have x. We have a vector like x, something like this, x1 to xn. X has n entries, x1, x2, etc., xn. So each entry I, like xi, of this vector is computed using equation 1. xi is computed using determinant of aib over determinant of a. xi is the entry I of vector x. And what is vector x? Is the solution of the system of linear equations. X equals b. Right? Is this clear to you?
Clear, Doctor.
Yes, Doctor, but the question, what is the compute the cameras rule or xi, what we can compute?
So you want to solve a system of linear equations, right? X equals b. You want to solve the system of linear equations, right?
Yes, Doctor.
Right.
So you already have a method for this using echelon form, reduced echelon form. That was one method, right?
Yes, but ax equal b, we have taken in echelon 4. In this topic, what's mean? In cameras rules or theorem 7, I don't know what can I solve this xi in this topic.
So let me tell you. So you already had a method to solve ax equals b. A very general method. Doesn't matter if a is invertible or not. You already had a very general method to solve a system of linear equations like ax equals b. So when a is invertible more than that method, based on echelon form, you have another method, which is Cramer rule, to solve system of linear equations. How does this method work? The Cramer rule method. How does it work? It works using equation 1. So in equation 1, you can compute entry I of your solution. You have a solution like vector x. You want to find each and every entry of that solution, right? You have a vector, you have a single unique solution, which is vector x, and you want to compute each entry of that solution vector x1, x2 to xn. And this theorem says how to compute xi. So in the exam, for example, sometimes we tell you solve the system of linear equation using echelon form, or sometimes we tell you solve the system of linear equation using Cramer rule. Then you should use theorem 7. And using this theorem is possible if and only if A is invertible. So in the cases where A is invertible, your coefficient matrix is invertible more than your traditional method to solve a system of linear equations, which is based on echelon form. You have another method to solve system of linear equations. And this new method is called Cramer rule or theorem 7. So what is Cramer rule? Cramer rule says when your metric coefficient matrix is invertible, then your system of linear equations for every B has a unique solution. And this unique solution, this unique vector for X is obtained using equation 1. So this equation says xi, the entry I of X of your solution is computed as determinant of AIB over determinant of A. Right? Is it clear to you?
Yes, doctor, it is clear. That means you have when a matrix A is invertible and have a unique solution, we take this formula. Okay?
Exactly. And you can use this formula to find your unique solution more than your echelon form. Sometimes in the exam, we ask you to use this formula, then you cannot use echelon form. Sometimes we ask you to use echelon form, then you cannot use this Cramer rule. Sometimes we don't say anything. So you can either use Cramer rule or the echelon form. It's up to you. But this rule is possible only when A is invertible.
Okay, doctor, thank you.
Okay. So is Cramer rule now clear to everyone?
Yes,
Yes,
doctor.
yes.
Doctor,
Yes, doctor.
doctor, please. What about if the determinant A equals 0?
Then A is not invertible. A equals 0 is not invertible.
If it's 0, that means it's singular, and we cannot use this rule, right?
Exactly. Yes,
So
exactly.
if you give us any question, and it was the terminal for it, it's equal to 0, then we say there is no solution, right?
You mean the system
No,
either
there is
has no unique solution, infinity or many solution?
yes. So it
No.
doesn't have a unique solution. So the Cramer rule is not applicable. When A is 0, then the Cramer rule is not applicable.
Okay, doctor, thank you.
So other questions, Mr. Muhammad Abdul Rasul, you have raised your hand. And also Mr. Ala Muhammad, you have raised your hand. Do you have any question? Okay,
اخوان
no.
رافعين ايديكم نزلوها. لو احتمال عندكم سؤال؟
محمد الحجامي، يسأل علاء، عندكم سؤال؟
تنملت. لا كانوا رافعين ايديهم عبالهم يعني عمود الامتحان يعني فظلت.
خالد انت سدل
No
ايدك
questions,
الأول.
doctor. Continue.
Okay,
Go
great.
ahead.
Let's continue. So, okay. So let's move to the next point. Next theorem. It is also an important theorem, and it expresses the relationship between inverse and determinant and adjugate. What is adjugate matrix? Let me first define what is adjugate matrix. Adjugate matrix of A is the transpose of cofactor matrix. What is cofactor matrix? So, cofactor matrix is a matrix like C, whose ij entry is Cij. So what is Cij? Can someone remember what is Cij?
That's
Cofactor of ij.
of element.
Sorry, please.
That's
It's contact. It's constant number.
of
One by one, please. Mr. Mohandes Mustafa, you first were talking.
that means the
Yes,
position
yes.
of item in matrix.
Sorry, please. I don't have your voice. Please repeat.
That means the position of item in matrix.
Mr. Ihab Ahmed, you say.
Yes, doctor. It's that we took to last session. It's -1 or the power of 1 plus 1 over the C dot. شباب ماركاتكم بالله عليكم.
So please repeat -1 to the power of.
Power of 1 plus 1.
Yes. Then.
Yeah. Over C dot. That's as I
No,
remember.
not. So
It's
not.
I.
So.
It's -1 os I plus J.
So Cij equals -1 to the power of I plus j,
Yes.
and determinant of capital Aij. And what
IJ.
was capital Aij? Capital Aij was determinant of
Terminate.
was the matrix resulting from removal of row I column j from A. So I wrote here what is Cij. Cij
Yes.
equals -1 to the power of I plus j times determinant of capital A ij. What is capital A ij?
It's
Capital
minor.
A ij is matrix obtained by removal of row I column j from A. Right? So Cij equals -1 to the power of I plus j, determinant of capital A, I, j. We already had this.
Yeah, by deleting the row I and column J, so we can determine it
Yes.
like that.
Aij is removing row I, column j from A. So Aij means removing row I, column j from A. So in this way, you can define matrix C or matrix cofactor in this way, using this formula that I wrote here. Each entry ij of this matrix C is defined in this way. Cij is defined as -1 to the power of I plus j times determinant of capital A Ij. Capital A, Ij is a matrix obtained by removing row I, column j from A. So we have this, right? We have matrix C. Aggregate of A equals transpose of matrix C, defined in this way. So above, you see the definition of matrix C, and aggregate is the transpose of C. Right? Is this clear to you? What is aggregate?
Yes, doctor, is that transport for C?
Sorry?
Is that C transporter?
Yes. C transpose is the same as aggregate.
Yeah, adjective, yes. Adjective.
Okay, so aggregate is defined as transpose of C. So then this theorem 8 says A minus 1 inverse of A equals 1 over determinant times adjugate of A, right? So theorem A says A minus 1 equals 1 over determinant of A times adjugate of A. So this gives you another method to compute A minus 1. You already knew a method to compute A minus 1. What was that method? So that method was based on this fact that those row operations that convert A into I, the same operations convert I into A minus 1. If you remember, we had this method to compute A minus 1. I say it again, those operations that convert A to I, they convert I to A minus 1. This was one method to compute A minus 1. Theorem 8 presents another method to compute A minus 1. You see, A minus 1 is 1 over determinant of A times
أي
adjugate of
الله
A.
يسلمك.
So what is adjugate of A?
نعم.
It is
اي والله
transpose of
الكهرباء
C,
قاطعين
metric C.
الكابلات
And
ونصلي
what is
الوفاء ان شاء
metric
الله نشتغل
C or
وياكم ان شاء الله.
cofactor matrix? It is computed
اي
using
لا ان
this
شاء الله بس يروحون نسوي ان شاء
equation
الله بس جزاكم
Cij
الله خير.
equals
خليك خليك قاطع على راسي.
minus 1 to the power of I plus J times determinant of capital A Ij. And what is capital A Ij? It is obtained by removing row I and column J from A. Right? Is this clear to you? This is another method to compute A minus 1. We already, in chapter 2, I think, we already saw a method to convert inverse. Now, in this part, in theorem 8, we see another method to compute A minus 1, right? So, let's see an example. So, this is matrix A, and we want to compute inverse of A. So, this is based on aggregate matrix. So we need to compute aggregate matrix. We need to compute matrix C, cofactor matrix, and then take transpose to compute aggregate matrix. So to compute cofactor matrix, we need to compute C11, C12, C13, C21, C22, C23, C31, C32, C33. Right? Okay. So what is C11? You tell me, what is formula for C11?
It's minus 1
It's
by
minus 1
1
minus
4 minus 2.
هاكو ماينس 2.
So this is Noor, you were talking first. Please.
it's determined of C11.
So C11 is minus 1 to the power of 1 plus 1. Then determinant of removing first
The first
row,
row and the first column.
column from A.
Yes.
And it is something like that. So minus 1 to the power of 1 plus 1 gives you plus 1. And this is determinant of a matrix resulted by removal of first row and first column. And in the end, you will get -2 for C11. In a similar way, you can compute C12, C13, and so on. For example, C23 equals -1 to the power of 2 plus 3, which is -1 to the power of 5, and it is -1, right? And determinant of matrix resulted from removal of row 2, column 3, and this is that matrix. And the determinant of this matrix is 7. So -1 times 7 gives you -7. In this way, you compute matrix C. So, right, in this way, you compute matrix C. And you take transpose of this matrix and you have aggregate. This is aggregate. Right? So matrix, what is matrix C? Matrix C is -2, then
-2,
then
3,
you tell me 3
and 5,
5, then
14,
14,
7, -7, -7.
-7,
One.
-7,
Yes.
and then
4, 1, -3.
1 minus
1,
-3.
-3. This is aggregate, right? This is sorry, cofactor. This is matrix C. And then you take transpose of this matrix and you get aggregate matrix. You see, right? -2, -2, 3, 5. The first row becomes the first column. -2, 3, 5, and so on. 14 -7
Yes.
-7 becomes the
So the
second column.
second column.
So you have aggregate over here as the transpose of cofactor matrix. And then if you compute determinant, the inverse of determinant times aggregate gives you A-1, right? Very easy. You compute determinant of A, you now have to compute determinant of A, and then aggregate times inverse of determinant gives you A-1, right? Is it
Yes,
clear?
Doctor.
Okay, so if this is clear to you, I want to tell you some trick. You have this relation, right? And you are lazy and you don't want to compute determinant of A. What can you do? You already have computed aggregate, but you are lazy to compute determinant of A. What can you do?
That's the same coefficient power transport.
So let me tell you. Multiply both sides of this equation by A. Then what will you have? You will have A -1. Sorry, it is, sorry, why? This went up. So you have A -1 times A gives you what? 1 over determinant of A. You tell me. Aggregate of A.
Multiplication by A.
Yes, aggregate of A times A. Right? You get this formula. So what does this give you? So you have A -1. A equals 1 over determinant of A, aggregate of A times A. So then what does this give you? A -1. What is A -1?
The same A.
It's the inverse of A.
Inverse A.
of A.
Identity matrix.
Identity. Yes.
Identity matrix equals 1 over
Educate.
On A.
1 over determinant,
Determinant of A.
then adjugate
A.
then times A. Right? Then multiply both sides by determinant of A. What you get? You have determinant of A
Multiplied
times
by
I gives
Yes.
you
Educate
adjugate
by
of
I.
A times A.
A.
This is a very nice formula. So what does this say? It says multiplication of aggregation of A, and A is always a diagonal matrix, and this diagonal matrix is the product or multiplication of determinant of A and identity matrix. Determinant of A is a number, right? Determinant of A is a number, and I is identity matrix. When you multiply this number, determinant of A, to I, the result is a diagonal matrix, so that the each element, each entry in the main diagonal of this matrix is determinant of A, right? So multiplication of aggregate of A and A gives you a diagonal matrix, so that all elements on the main diagonal are the same, and that this same value is the determinant of A. Let's see this on our example. So we computed aggregate of A, and we have A. Multiplication of these two, aggregate of A and A, gives you this matrix, 14 times of identity matrix. So what is determinant? What is determinant of A? From this, you tell me, what is determinant of A?
Diagonal matrix with the 14.
14, yes. Determinant is a number, right? Determinant is not a matrix. It is a number. So determinant is 14, right? Determinant is 14. So we, instead of computing determinant of A, which is kind of time consuming, boring, we can multiply aggregate of A with A, which is easier for us, and the result always will be a number times identity matrix. That number is determinant based on the relation that we showed here, right? So in this example, your determinant is 14. So in order to continue our example, A minus 1 equals 1 over 14, because 14 is determinant, times aggregate. This is aggregate matrix that we already computed. So A minus 1 equals this matrix. Right? Is it clear?
Not clear. عين سادنا العزيز الله
Is this clear to you?
Yes, doctor.
لا لا
Okay, okay. So you have this
الكهرباء
relation, right?
تبغى
A
يصير
minus
عشان
1 equals 1 over determinant aggregate. First, you try to compute aggregate. Aggregate is transpose of C, cofactor matrix, and you computed aggregate like this.
بس خليك
Now, you need to compute determinant, but you are lazy and you don't want to spend too much time and effort to compute determinant. So you try to use this formula to find a better way to compute determinant. You multiply both sides of this formula by a. A minus 1a gives you 1 over determinant aggregate a. Then a minus 1a equals I, and then you have I equals 1 over determinant of a aggregate a. Then you times both sides by determinant of a. So you have determinant of a, which is a number, a scalar, times identity matrix equals aggregate of a times a. So by multiplication of aggregate of a and a, you get a matrix which is in the form of a scalar times identity matrix. That scalar is determinant of your matrix. Over here, you compute aggregate of A times A, and it gives you 14 times of I. That value 14 is determinant. So A minus 1 becomes 1 over determinant, which is 14 times aggregate. And this is the resulting matrix, A minus 1, right?
Doctor, this 9 vectors, where we was used it?
So sometimes in the exam, we may ask you explicitly to compute A minus 1 using aggregate. Then you should use this method. Sometimes then in the exam, we may ask you to compute A minus 1 using echelon form and row operations. Then you should use the method that you already learned. These two are two different methods to compute A minus 1. You should be familiar with both of them. Right?
That should you compute the 9 factors in this exam?
Sorry, I didn't get your question.
I mean, that's the 9 factors, CI. That should we compute
Yes.
this?
Yes, you should compute the whole C cofactor matrix, which has 9 entries in this example. You should compute C11, C12, etc., C33. You should compute 9 entries of matrix C. Right? Any other question? Question? Feedback?
No, doctor. Thank you, doctor.
Okay, no question. Thank you, and
Thank you, doctor.
Doctor,
thank you.
excuse me, doctor. I have one question about the exam.
Tomorrow, let's talk tomorrow because now you should discuss among
Just one
yourself,
question, doctor. It
and
will
then
be in
we'll
our.
talk it tomorrow.
We'll talk about this question in our discussion. So please, I want your answer. If we take in the first exam and the subject that we will take in this exam will not, it will not be in the final